A very good day, grade 12 learners. Welcome to today's subject lesson, Mathematical Literacy. That is, my name is Mampani Kekana. This lesson is brought to you by the Gauteng Department of Education in collaboration with Siboney Discovery Center and broadcast by Pakama Research and Development. Okay, boys and girls, welcome. So we are going to continue today with our data handling. So we are going to do some recaps. Okay, now boys and girls, remember last week we were busy with developing questions. So today we are going to look at how to summarize data. So today's section is about summarizing data. So what you should expect at the end of the lesson, you should be able to do the following. You should be able to define terminologies used in data handling. So you should be able to summarize the collected data using measures of central tendency and measures of spread. And you should be able to analyze and interpret the summarized data. Okay. Now, if you remember very well, boys and girls, last week we discussed some of these terminologies. So I'm not going to discuss all of them today, but I'm just going to focus on the ones that we're going to work with today. So for summarizing data, the following terminologies are very, very important. And remember, terminologies are part of examination. So it's very important that for each and every topic or each and every section, you know the terminologies. And remember, I said you don't necessarily have to define terminologies exactly as they are maybe in a textbook or in your study manual. So what you can do is you can try to come up with your own definitions as long as they are long enough and relevant. So just try to make them simple and relevant. So for today's lesson, our important terminologies are interquartile range. So the first one is interquartile range. So remember that interquartile range is the difference between quartile 3 and quartile 1. So if they ask you to define interquartile range, you must know that interquartile range is the difference between quartile 3 and quartile 1. Okay, so then the next one is mean. Okay, now for mean, how can we define a mean? In simple terms, a mean is the sum of values. If you are given a list of values, the sum of values divided by the number of values. So if you've got 10 values, you add up the 10 values and then you divide them by 10. So the next one is measures of central tendency. What do we mean by measures of central tendency? Now, measures of central tendency are values that show the position of set of data. Those are values that show the position of set of data. So we'll come back to that one later on as we are busy with activities. And then the next one, okay, still on measures of central tendencies. Measures of central tendency, remember, like I said, those are the values that show the position of set of data. So we've got mean, we've got median and mode. So mean, median and mode, all of them together, the three of them are called measures of central tendency. Then we've got the next one, which is measures of spread. Okay, measures of spread are values that show how a data is spread out. Okay, measures of spread are the values that show how a data is spread out. Okay, then the next one we've got median. Now for median, it's the middlemost value. If you are given a list of values is the middlemost values in an arranged data. So the data must be arranged. It's not just the middle number or the middlemost number, but it's the middlemost number of arranged data. And then we've got mode, and then for mode it's the value, okay, a value or an item that appears the most. If you are given a list of items or a list of values, then mode will be a value or an item that appears the most. Okay, then the next one, boys and girls, is an outlier. Okay, outliers. The definition of an outlier, remember we said last week, if you are given a list of numbers or a list of values, then when you look at the values, you see there's either a number that is too small or too big compared to the rest of the numbers. Okay, so an outlier, it's a value that is too small or too big compared to the other values. That is in simple terms. Right, then the next one, percentile. Now, percentile, it's, in other words, a percentile, it divides values into 100 equal values. So that is a percentile. Now when we come to percentile, a percentile divides a set of data into 100 equal values. Then the next one is quartiles. Okay, now a quartile divide the data into 3 points to form 4 groups. Okay, so quartiles divide a set into 3 points to form 4 groups. The next one is range. Now a range is the difference between the highest value and the lowest value. If you are given a list of values or a set of values, then the biggest value minus the smallest value, that will give you the range. Or you can say the highest value minus the lowest value, that will give you a range. Or you can say maximum minus minimum, that will also give you a range. But in terms of a definition, we say it is the difference between the biggest number and the smallest number. Or you can say the difference between maximum and minimum. Okay. Now, the next one that is very important for this, summarizing data. What do we mean when we say we need to summarize data? Now, when we summarize after we collected the information, and then we have to summarize the data. Now, to summarize the data means we make the information simple. We make the data simple to be interpreted. If I'm collecting information or I'm collecting data, and then after that I need to summarize it, that means I have to make it simple in order for any other person to interpret the data. Okay, now these are some of the terminologies that we'll be working with throughout summarizing data. Okay. Now, summarizing data, as I indicated, in simple terms. So in this case, they say collected data that can be summarized by using measures of central tendency and spread. Then, like I said, measures of central tendency, okay, it's a single value that shows a central position of a data. Then you've got 3 of them. We've got mean, median, and mode. Then again, for this one, we're going to look at the first measures of central tendency, which is mean. Okay, in some cases they say mean or they say average mean. So you must know in an examination, when they say or the examiner says mean or average mean, the examiner would be referring to the same thing. Now, in terms of a formula, mean is sum of values in the data set over total number of values in the data set. Sum, that means you are adding, and then you divide by the total number. So that means how many values are there. Okay, let us look at the example. Let's say you obtain the following results for 7 subjects. Most of you are doing 7 subjects, of course. Then we need to analyze the results. We want to make the results very simple, so that maybe we need to show it to your parents, or we need to show it to your school principal to see how your performance is. So your educator might calculate your mean, or your principal might say, what is the mean of all the subjects? Okay, now how do you calculate the mean? Like we said, the mean is sum of values divided by the total number. So for this one we need to add. So the mean is 70 plus 62 plus 54 plus 60 plus 62 plus 82 and plus 58. Okay, now it's very important that after writing down the addition you need to count. Originally we had 1 2 3 4 5 6 7, so we have 1 2 3 4 5 6 7. So then we say all over 7. There we've got the sum. Okay, then you take your calculator. Very important, boys and girls, that you need to indicate each and every step. In Mathlit, we do encourage that learners must show all the steps. Okay, so for this one, if you take your calculator, you say 70 plus 62 plus 54 plus 60 plus 62 plus 82 plus 58, and this gives us 448. So we need to indicate that 448. Then from there we say 448 divided by 7, and that will give us 64. Okay, if you look at the values that are given, they are given with the units percentage. So but when you do the calculations, you can just ignore the unit for now. Okay, then but in the end you can just indicate that this is actually 64%. Right, so you indicate the sum, the addition, and then there is the sum, and then the answer. So the answer there is 64%. Right, then the next one. Okay, so for this one we're still looking at mean or average mean. Now boys and girls, it's very important that you read a question and you understand what is required in a question. Okay, now for this one we still given the formula mean equals to sum of all values in the data set over total number of values in the data set. Then they say an example, you obtain the following results for 7 subjects, 70%, and then there you've got LO, but the mark for LO is not indicated. And then you've got 62%, you've got 54%, you've got 60%, 62%, 58%. Forget about the previous question or the previous example. Here we're looking at a different way of asking a question, okay, about a mean. Right, so then this one, they say determine LO's mark if the mean value of all subjects is 64%. Determine LO mark. So this one we are not calculating the mean is given. So when the mean is given, we have to find the mark of one subject. We've got the marks of 6 subjects, but we don't know the mark of one subject. Okay, now this is what you must do. First thing, we need to add. So we've got 70, we've got LO, we've got 62, we've got 54, we've got 60, we've got 62, we've got 58. Now the same procedure. Then we say 70 plus, we don't know the mark for LO, but we still write LO. Okay, in some cases the examiner will use a letter, maybe capital letter A or capital letter B to represent LO. But in this case, we can just leave it as LO, and then we say plus 62, never mind the units, plus 54, plus 60, plus 62, plus 58. Okay, now imagine if the mark for LO was given. It means we're going to have 1, 2, 3, 4, 5, 6, 7 marks there. Okay, then we still say all over 7. Okay, then we divide by 7. We're supposed to get the mean. So, but the mean is given. We say this one, if we add up all the marks and divide by 7, we're supposed to get 64. Okay, now boys and girls, unfortunately this is sort of mathematical, so but we need to think. Even if you check the previous question papers, you will still find the questions that are similar to this one. So it's very important that when you prepare yourself for a test or for an exam, you familiarize yourself with this type of questions. Okay, now what do? We've got 70, then we need to add. Okay, we need to add here. So what we are going to do is we add 70 with 62, with 54, with 60, with 62, with 58. If I add only those values, I say 70 plus 62 plus 54 plus 60 plus 62 plus 58. Then I get 366. So, but I still have LO there. So I can say LO plus 366. Where am I getting 366? Is for adding the values that are given there. Then I divide by 7, and then this is equals to 64. Remember, boys and girls, we are looking for the value of or the mark for LO. Now, to get the mark of LO, we have to find the value of that LO. So what we do for this one, we are going to do the cross multiplication. Now, you know, most of you know about a cross multiplication. If I cross multiply there, and then I cross multiply, or any other method that you understand better. When I cross multiply the top one multiplied by the bottom one, I still get the same thing. I will still get LO plus 366. Okay, then this one, the bottom one multiplied by the top one on the other side. If I take 7, I multiply by 64, then I get 448. You get 448. Now we are looking for the value of LO. So for this one we say therefore LO equals to 448 minus 366, and then the value of LO is 448 minus 366. There's 82. Okay. Remember, this one is a little bit longer than when you calculate mean only. In this case, the value of the mean is given. We have to find the mark of, or the missing mark for LO. So this is how we calculate it. Okay, remember this is just an example, and then we'll come to the activities later on. Okay. Then another type of measures of central tendency, we've got median. From the definition, you can see that the middle value of an ordered data set is not just the middle, but is the middlemost of ordered. So it means the values must be in order. So when they ask you to calculate a median, you have to make sure that you arrange data in ascending order. Ascending order or descending order, but we prefer that you arrange them in ascending order. Remember, up for up, and then we look for, we have to determine the median there. Okay, let us look at how we determine a median. Let us look at the example. Here you are given the marks of 7 subjects: 70, 82, 62, 54, 60, 62, 58. Okay, now we know that median is the middlemost number, so you can't just go straight and say, okay, 54 is the middle number or the middlemost number. You must first check if the numbers are arranged in ascending order. Okay, now these ones you can see they are not arranged, so we need to arrange them. Okay, so we start with the smallest number. So the smallest number in this case is 54. So we can say 54, and then the next number is, so we can just cancel 54 to indicate that we've already rewritten down that number. And then the next number is 58. So we've got 58. So we can just draw a line. After 58, we've got 60. Okay, after 60, we've got 62. Okay, then after 62, we've got another 62. Okay, and then after 62, so this one we've got 70. Okay, we need to check. Okay, originally we had 6 numbers. We need to check 1, 2, 3, 4, 5, 6. Our numbers are still 6. So the median, which is the middlemost number of the arranged data. So for this one we need to check. So in the 6 subject, we've got 54, we've got 70, we've got 58, we've got 62. Now we need to check. Boys and girls, if you are given a number of values, if those values are even, okay, even, like for instance we've got 4, if you take your fingers, you've got 4, there'll always be 2 fingers in the middle. So it means if the values are even, then you are going to have 2 numbers in the middle. Okay, then if the numbers are odd, if you take your 3 fingers, then you'll always have only 1 finger in the middle. Okay, so for odd number of values, you'll always have 1 number, but if the values are even, you'll always have 2 numbers. Now what do you do when you have 2 numbers? You take the middle 2 numbers. So in this case we've got 60 and 62. So 60 and 62, we add them together. So for that one it must be 60 plus 62, and then we divide it by 2. Very important that you write it down, you show the method, and then from there we add. If you take 60, you add it with 62, that will give you 122. Then you still divide by 2, so in the end you get 61. Okay, so our median is 61. So it's the number that is between 60 and 62. Okay, right, then the next one, we're now going to look at another measure of central tendency, which is mode. Now the data, okay, mode is actually the data value that occurs most frequently, or the value that appears the most, or an item that appears the most. Okay, so it can be for both numerical or categorical. Now let us look at the example. They say you obtain the following results for 6 subjects: 70, 62, 54, 60, 62, and 58. Right, we need to check which number appears the most. Which number appears the most there, we need to check. Now if we start, for this one we don't need to arrange it, boys and girls, we don't need to arrange. Okay, you can just do some observation there and check which number appears the most. So if we look at 70, there's only one 70 there. So this is the only 70. Then when we look at 62, we've got 62, we've got another 62 there. So 62 appears 2 times. Let us look at the other values. 54, we've got only one 54 there. Right, and then the next one, 60. Okay, we've got only one 60, and then we have already indicated 62 appears twice. Then 58 appears only once. Okay, so it means in this case the one that appears the most is 62. So this one we just write it down. We say and the mode is 62. Okay, please remember to indicate the percentages as well, just the same as the previous one. This the median is supposed to be 61% in the end. Okay, then let us move on to the next. All right, remember we said measures of central tendency, we use them to determine the position of data set. In other words, we are actually analyzing, making the data very simple for someone to interpret. So if we have to calculate mean, median, and mode, okay, and then now somebody needs to interpret that data, okay, which one will be the best? So we have to choose between the three. Which one will be the best? Because an interpreter might choose one which is biased, okay. So what must we look at when we make a conclusion about certain information or certain data? Okay, now for this one they say you must know when to use the most suitable one. For example, if you are given, let's say these are your marks, we've got 1, 2, 3, 4, 5, 6, 7. In one subject you got 70%, the other one 62, 54, 60%, 8%, 58%, and 82%. You are doing so good in all the subjects except one subject. Okay, you just have that one subject that you are struggling with. No matter how hard you study, but you're struggling with that subject. So when someone interprets or your mom interprets the results, you can see that, okay, but most of the subjects are good, but suddenly there's only one subject that is too low. So this one we say is an outlier because you can see it is too low compared to the other percentages. So in this case we say 8% is an outlier, like we said, the value in the data that is far away from others. Okay, and then we need to decide which one are we going to use. If we have to calculate the mean in this case, all right, if we have to calculate the mean, let's see. If we calculate the mean, we say 70 plus 62 plus 54 plus 60 plus 8 plus 58 plus 82. Okay, then we say all over. How many values are there? 1, 2, 3, 4, 5, 6, 7. So there's 7 of them. If you take your calculator, it's 70 plus 62 plus 54 plus 60 plus 8 plus 58 plus 82. Then we divide it by 7, we get about 56.2. So this will be 56.2. Okay, of course it must be rounded off to 56. Okay, so now you can see that after calculating the mean, in the end it's 56. So it means it doesn't matter how good you did in the other subject, but you can see that when somebody summarizes your marks, you can see that on average or according to the mean, you're supposed to get 56. Now, what do we mean by the mean? The mean, it means if we have to share the marks evenly. Okay, so it means actually each and every subject you would get 56. Okay, so you can see that you've got 70 there, you've got 60, you've got 82, but all of a sudden everything is down now. Okay, so it might look like you're not actually doing good. Okay, now but let's compare with the median. Now for median, what is our median? A median is the middlemost value. So let us look at the values. The values are not in order again. So what we can do is we can rearrange this from the smallest to the biggest. So I'm going to write the 8 is the smallest, and then the next one is 54. Okay, you can just cancel. Okay, and then after 54 it's 58. Okay, we can cancel 58. After 58 it's 60. Then after 60 we've got 62. Okay, after 62 we've got 70. After 70 we've got 82. Okay, now we need to check. Initially we had 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, so we need to recount after that. Now 7 is 7 an odd number or an even number? 7 is an odd number, so that means we have only one number in the middle. If I count on the left hand side, so this is 1 1 2 2 3 3, then we've got 60. So 60 is our median. Right, then we've got again mode. Do we have a mode in this case? Do we have any number that appears? We've got 70, it appears once, 62 once, 54 once, 60 once, 8 once, 58 once, and 82 once. So we've got, in this case, we don't have mode, okay? But you don't say the mode is 0, but you say there's no mode, or just say none. Okay, now we need to interpret the results, okay? If they have to use 56, okay, or in this case we need to check, would you prefer that they must use 56 or they must use 60? Would you prefer that they must use mean or median? Of course, obviously you would prefer that they might use a median, okay, because you can see the median is higher than the mean. Okay, you are doing so good in almost all the subject. I mean, it's almost all the subject, but only that one subject that you're struggling with. So can you see that 80% actually brought the mean down? But in this case, the median, what does that mean? It means at least in 50%, half of the subject you are getting at least 60 or more. So that is good. Okay, so if you get a question like this one and then in the end they ask you, would you prefer to use mean, median, or mode? So obviously in this case we don't have mode, then we are left with mean or median. Then which one? We can't use mean because there's 8% there, which is an outlier, and then obviously it's bringing the summary down. Okay, so we say mean is the best used if the data doesn't have an outlier. So if we didn't have that 8, we were going to choose mean. And then in this case we say median is the best or is best used if data set does have an outlier. Like we say, which one are we using? We are using 60%, which is median, because we do have an outlier. So you must just remember that. And then when do we use the mode? Mode is best used if data is categorical. Okay, so in other words, if the information is not in the form of numbers, they say if asked to choose the most popular item, e.g. most popular size of pair of shoes. Okay, so this one, it means we can choose, or we can choose to use a mode. Okay, then now we just summarizing, then we look at the advantages and disadvantages of measure of central tendency. It's very important that you know these, boys and girls. Okay, so because the examiner might ask you maybe an advantage and disadvantage. The same way the examiner might ask you which measure of central tendency will be the best. Okay, now when we look at the mean, what is the advantage? The advantage of using the mean is what it's useful when we compare set of data. In other words, when we compare, let's say we've got grade 12 learners, and then we've got 12A and 12B, then now we need to compare the results of the two classes. And then we can be used for both continuous and discrete data. Remember, last time we spoke about continuous and discrete data, and then continuous, remember we said it's that data that must be collected by measuring, okay? And then discrete data is the data that must be collected by counting. The disadvantage is it is affected by an outlier. It might give a wrong impression because of an outlier. So that is why we said if there's an outlier, we would not prefer to use mean. Then median, it is not affected by an outlier, but very important, you need to arrange the values. And then mode, it is not affected by an outlier. It can be used for both categorical and numerical. Okay, so you must just remember that. Okay, then we're now going to look at measure of spread. Okay, now measure of spread, sometimes they call it measure of dispersion, is the value that gives an indication of how data is spread out. Okay, you must just remember spread. Okay, the value that gives an indication of how data is spread out. Okay, like measures of central tendency, in this case measures of spread, we look at the following. We look at range, we look at quartiles, we look at interquartile range, and we also look at percentiles. Now, what do we mean by quartile, or what is a quartile? Now, a quartile divides an arranged set of data into 3 points. That is lower quartile, middle quartile, and upper quartile. Lower quartile, in some cases they say is Q1, and then we also have median, Q2, and upper quartile as Q3. Okay, so I think I need to take a break, boys and girls, just 1 minute, and then I'll get back to you. Okay, thank you, boys and girls. Welcome back. Let us continue. Remember, we're still busy with quartiles. Okay, and then I was still explaining the definition of a quartile. It's very important that you know it. Okay, we say a quartile divides an arranged set of data into 3 points. That is lower quartile, middle quartile, and upper quartile. In some cases, they will say lower quartile is quartile 1, or we use the notation Q1 to indicate that this is lower quartile. And then we also have quartile 2. Quartile 2, of which in some cases they say it's a median. And then we've got upper quartile, which is denoted as quartile 3. Okay, now we need to analyze the following results. They say, for example, analyze the following results. Okay, so for this one, they mean we need to determine quartile 1, quartile 2, and quartile 3. Okay, we need to determine quartile 1, quartile 2, and quartile 3. Okay, we need to check. We have to check the values that are given. We've got 60, we've got 63, we've got 68, 72, 77, 78, 81, 85%, 91%, and 95%. All of them are in percentages. But I remember I said for the sake of calculations, you can just disregard the percentages now, but in the end, when you write down your final answers, you indicate the percentages. Now, before we can determine the quartiles, so we need to be sure, we have to be sure that all the values are in order from lowest to the highest. Okay, so we can check, just double check. You can see that all these values are in ascending order, that is from the smallest to the biggest. And then how many are they? We said there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is an even number. Okay, so if it's an even number, it means there are two values that are in the middle here. So let's check. So 60, so it's 1, then it's 2, it's 2, then it's 3, it's 3, then it's 4, it's 4. Okay, then you can see that you now have two numbers in the middle, like I indicated. When we counted, there are 10, then it means there are two values in the middle. Okay, now if there are two values in the middle, and then it means we have to determine quartile 2. Okay, let me put it in this way. The reason why I have to start with quartile 2. Remember, we've got quartile 1, we've got quartile 2, and quartile 3. But in order to find quartile 1 and quartile 3, unfortunately, we have to start with quartile 2, which is the median, like I indicated in the previous slide. So we have to start with quartile 2 so that we will be able to determine quartile 1 and quartile 3. Okay, so we've got this, our middle number. So we say 77 plus 78, then we divide it by 2. So if you use a calculator, you say 77 plus 78, then you divide it by 2, then this will give us 77.5. So 77.5%. Okay, now this 77.5% is our quartile 2. So somewhere there, between 77 and 78, we've got our quartile 2. Now we have to check if our median is between 77 and 78. Now we need to check how many values do we have now on the left hand side. We've got 1, 2, 3, 4, 5, and then on the right hand side we've got 1, 2, 3, 4, 5. Okay, now how do we determine quartile 1? Quartile 1, it's now the number that is in the middle of the values on the left hand side of the median. So all these values on the left hand side, the middlemost number, so the number that is in the middle here is 68, and then now on the right hand side of the median we've got 78, 81, 85, 91, and the 5, we also have 5. Now 5 is an odd number, obviously there's only one number in the middle. So quartile 1 and quartile 3 are actually, the quartile 1 is on the left hand side of the median, and then quartile 3 is on the right hand side of the median. Okay, so in this case 68 is our quartile 1, and then 85 is our quartile 3. So this one we just have to indicate is just 68%, and that one is 85%. So there's no need for calculations there. It's just a matter of identifying the value that is in the middle, and then we write it down. But unfortunately with the median, we had to add and then divide by 2. And it's very important that when you do the addition there, you say 77 plus 78, you write it down, you write down the answer. And then from there you say divided by 2. So for that one, okay, for that one, okay, it's fine. Right, so let us move on to the next one. Okay, then the next one is interquartile range. Remember we spoke about interquartile range as well. We said is the difference between upper quartile and lower quartile, the difference between quartile 3 and quartile 1. So they say if the interquartile range is small, then the data is clustered together, and if the interquartile range is large, then the data is far apart. Okay, now let us use the very same values. Okay, the very same values, Jabu's results that are already arranged, so we don't need to arrange them in order. Okay, now we need to understand interquartile range is the difference between upper quartile and lower quartile. So the formula there is interquartile range. Normally they use the abbreviation IQR. So for IQR, we say it's quartile 3 minus quartile 1. That is the formula. If the examiner would not give it to you. So IQR is quartile 3 minus quartile 1. Simple as that. So if you look at the previous slides, okay, you see that we have already calculated quartile 1 and quartile 3. So we've already calculated quartile 1 and quartile 3, so we can use the very same information. So for that one, remember we said this is our median, that is our quartile 2, and then we said our quartile 3 it's 85, and then our quartile 1 is 68. Okay, so we said for quartile 3 it's 85 and quartile 1 it's 68. Then we just calculate the difference. So this one is 85 minus 68. Okay, so you just do the substitution. 85 minus 68. Please make sure that you use your calculator. 85 minus 68, then the answer is 17. And that is how we calculate interquartile range. So the moment they say calculate interquartile range, then you know that is Q3 minus Q1. Okay, please do not confuse it with range. Remember, range we said is the highest value minus the lowest value, or the maximum minus the minimum. Okay, then the next one is percentiles. Then the definition of percentiles is measure of central spread that divides an arranged set of data into 100 equal parts. So when we divide it into, remember quartiles, it's got 3 points, but it divides into 4 equal parts. Okay, but percentile, it divides into 100 equal parts. Okay, and then we also have box and whisker diagram. Okay, box and whisker diagram. It's a diagram that displays 5-number summary. Now, when we talk about 5-number summary, we are referring to minimum, quartile 1, quartile 2, quartile 3, and maximum. So when we talk about 5-number summary, we are referring to the smallest value, and then quartile 1, quartile 2 or median, quartile 3, and then maximum. Okay, now it's very important that you understand the picture, or a picture of box and whisker. Okay, so you can see that we've got a box and we've got whiskers there. Okay, then the near end of the whisker we've got the minimum, and then the near end of the box we've got a lower quartile or quartile 1. And then in the middle there we've got median, we've got upper quartile or quartile 3, and then we also have maximum there, that is the highest. So every time when you see a picture of box and whisker, you must know that this end is minimum and this one is lower quartile. This represents median, quartile 3 or upper quartile, and then that one is maximum as indicated there. So that is in terms of quartiles. Then when we come to percentiles again, remember the box and whisker can be sideways or upright. So again, but the points are still the same. There we've got the minimum, which is the smallest, and we've got lower quartile, we've got median, we've got upper quartile, we've got maximum. Okay, then if you look at the lower quartile, remember lower quartile we said it's also quartile 1. Okay, but in terms of percentiles, they say it's 25th percentile. So when you see quartile 1, or you see lower quartile, or you see 25th percentile, you must know that those three are referring to the same thing. Okay, and then we've got median. Okay, median, quartile 2 or 50th percentile, the three of them are referring to the same thing. Upper quartile, quartile 3 and 75th percentile are referring to the same thing. Okay, and then you can see that this one is the range. Okay, now for the range, it's the maximum minus the minimum, and then we've got interquartile range, which is between lower quartile and upper quartile. Okay, so that is the picture of box and whisker. Okay, then now we're going to look at activities, boys and girls. Our first activity was taken from Eastern Cape Prelim 2021, paper 1, question 3. Okay, remember data handling, it's in paper 1. Okay, so this one, the information is mining plays a significant role in the economy of our nation. The information alongside indicates how the mining industry performed in 2019. Okay, there you've got the information that is given, right? Then the very same table, they say use the information in the table to answer the questions that follow. 1.1, determine the median value of the total sales. Determine the median value of the total sales. Now the median is the middlemost value of the arranged data. That is the median. Then we also have to make sure that we choose the correct column. Okay, it can't just be any of the, this one says total sales. Now total sales, there is the column for total sales, median. Okay, so what we can do, we can first write down or rewrite the values. So there we've got 47.6, we've got 22.8, we've got 13.3, we've got 71.4, we've got 72.6, we've got 124.6, and then we've got 139.3. Okay, how many values are there in the table? There's 1, 2, 3, 4, 5, 6, 7. There's 7 values in the table. Then after rewriting them down, we need to count as well. There's 1, 2, 3, 4, 5, 6, 7. Okay, median is the middlemost value of the arranged data. Now we need to check, are these data arranged? Okay, they are not arranged. We need to arrange them. Okay, we are going to start with the smallest one. It's 13.3. So 13.3 is the smallest one. Okay, we can just cancel it. The next one after 13.3, it's, okay, we check 22.8. Okay, then we can just cancel 22.8. Then after 22.8, we've got 47.6. Okay, we can just cancel 47.6. After 47.6, we've got 71.4. 71.4, and then we've got 72.6. We've got 124.6. And then we also have 139.3. Okay, let's just cancel these ones just to show that we rewrote them. Okay, you still have to count. Originally we had 7, so 1, 2, 3, 4, 5, 6, 7. There are still 7, so that you don't leave any number out. If there are 7, 7 is an odd number. Okay, remember, an odd number is any number that is not divisible by 2. An even number is a number that is divisible by 2. Okay, so if we've got an odd number of values, it means we've got only one value in the middle. Right, let's see. So if I cancel 1 on this side, 1 on the other side, 2, then 2, then 3, then 3. See, I'm left with only one value in the middle. So it means in this case, our median is 71.4. Okay, now remember, this is the information, this is the data that must be interpreted by someone. Okay, if you check in the table, they say total sales and then it's in billions. Okay, so if somebody has to interpret this, that person will say this is actually 71.4. Okay, 71.4 watt. Okay, so you need to indicate. So this is actually not only 71.4, but it's 71.4 billion. So this is in billions. That is why I said when you do the calculations, you can just leave the units out. So this is 71.4 billion rands. Okay, 71.4 billion. For the sake of calculations, you can just leave the word billion out, and then but in the end you have to indicate, because 71.4 would actually be incorrect. Okay, then the next question, still taken from the same province. They say use calculations to determine if the interquartile range for the total sales of the met and minerals is less than 101 or 101 billion rand. Okay, so use calculations to determine if the interquartile range, or just interquartile, supposed to be interquartile range there, for the total sales. Okay, now we have to look at the total sales. Okay, actually if you look at the previous question where we were given where we had already arranged, okay, but it's fine, we can arrange it again, we can arrange them again for this question. Remember our arrangement for this, because for interquartile we need to know IQR is equals to Q3 minus Q1. So that means we need to know what is our upper quartile and what is our lower quartile. To find the upper quartile and lower quartile, we need to arrange them. Yes, we have already arranged that in our previous one, but we can do it again. We said the smallest is 13.3, and then after 13.3 we said 22.8, then after 22.8 we said 47.6, then after 47.6 we said after 47.6 we said 71.4, then after 71.4 is 72.6, after 72.6 is 124.6, and then 139.3. Okay, we need to check. There are 7, they're supposed to be 7. 1, 2, 3, 4, 5, 6, 7. So all of them are there. What are we looking for? We're looking for quartile 1 and quartile 3. Okay, but remember we said even if you need quartile 3 and quartile 1, you need to start with quartile 2, which is our median. So the previous one we had already identified that 71.4 is our quartile 2. So we start with quartile 2. So there's 71.4. So we've got 1, 2, 3, 4, 5, 6, 7. 7 is an odd number. There's only one value in the middle, which is 71.4. Now we check on the left hand side how many values are there. So this is our quartile 2. There's 3 values. That means only one value in the middle. On the right hand side, only one value. So this one is the middle of the values on the left hand side of the median. So this will be our quartile 1, and this one will be our quartile 3. Okay. And then from there we can now do the substitution. IQR is quartile 3 minus quartile 1, so we can easily say IQR equals to 124.6 minus 22.8. Remember our question is we need to determine if the interquartile for the sales is less than 101 billion. Okay, then we say 124.6 minus 22.8, then we get 101.8. 101.8. Remember this is in billions, so for the sake of calculations we ignored the billion. So but this one we can say, so our answer there is 101.8. Determine if the interquartile for the total sales of the metals and minerals is less than 101 billion or 101 billion rand. It is actually more. Okay, so it's not less, it is more. Okay, so you must just indicate that it is more. Okay, we can now move on to our next question. Still taken from the same province, same question. Okay, that is prelim 2021 1.3. Okay, determine the mean number of direct employees in the mining industry. Give your final answer to the nearest 1,000. So the main words here, we've got mean, and then we also have nearest 1,000. So you should be able to calculate the mean. Now for the mean, it's the sum. So we know mean must be the sum. Determine the mean number of direct employees. The mean number, direct employees. These are direct employees. Okay, there's 1, 2, 3, 4, 5, 6, 7 values. Make sure that you add all of them. So you can just indicate 10, 846 plus 19, 693 plus 15, 728 plus 19, 092 plus, unfortunately I don't have enough space there, plus 95130 plus 164 513 plus 92230. Okay, remember the mean we need to add, that is the sum. So let's check. We said we've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then we need to divide it by 7. Okay, now you need to use your calculator. So it's 10, 846 plus 19693 plus 15, 728 plus 19092 plus 95130 plus 164 513 plus 92 and then 230. Okay, then when I add all of them, I get the number there is 417,232. Okay, 417,232, and then I divide it by the number they are divided by 7. Okay, then when I divide it by 7, and then I get 59,000. Okay, so 59,000, I'm going to write it there, 59,604, 57 and so on. Okay, now I have to check. Have I answered the whole question? Yes, I have determined the mean, but there's an extra instruction there. Give your final answer to the nearest 1,000. Okay, so this value is in 1,000 is 59,000. So we need to round it up to the nearest 1,000. So 59,604, we know that it's between 59,000 and 60,000 in terms of thousand. This value is between 59,000 and 60,000. But is it closer to 59,000 or closer to 60,000? But it's more closer to 60,000 than 59,000. So therefore the rounding is 59,000. I'm sorry, 60,000. Okay, so in this case, unless if this value, the 604, this one was less than 500. Okay, if it was less than 500, let's say it was 400 or 480, then we would say 59,000. But because once it's 500 or more, it will change to the higher number. Okay, so that's number 1.3. We have answered there. We've got our mean and then the rounded answer as well. Okay, then the next question, still on the very same table. Write down the modal value. Modal value, the word modal comes from the word mode. Modal value for royalties paid. Give your answer in number format. Okay, now we need to check. Royalties paid is this column. Now which value appears the most there? If you look at 802 million, appears only, there's only one value there, right? 362, there's only one value there. Okay, 2.1, there's two of them. Then 288 million, there's only one. 1.12 billion, there's only one. So the value or the royalty paid that appears the most there is 2.1 billion. So we can write it down, 2.1 billion. Okay, give your answer in number format. Okay, so for this to be in number format, it means we don't want this word billion. Okay, so it's like if you've got 2 million, then you're just going to indicate 2 and 6 zeros. But actually, how do you change from 2 million okay, in weight to the number format? You just take 2, you multiply by 1 million. Okay, so for this one, it means we can take that 2.1, then we multiply by 1 billion. So if you multiply by 1 billion, a billion is 1 and 9 zeros. Okay, 2.1 multiplied by 1 billion. Okay, so if you take your calculator, you say 2.1 and then you multiply by 1 and 9 zeros. Okay, 1 2 3 4 5 6 7 8, then it's 9, and this will give us 2 1 0 0, and then it's actually 2 1, and how many zeros now? 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, so the number format. Okay, so the number format is 2 billion 100 million. Okay, so it's 2 billion 100 million. So there's 3 zeros, and then 100. So this one is 2 billion 100 million. That is the number format. Okay, so far so good. Then the next question, boys and girls, is we're now going to look at how we answer questions based on box and whisker. Okay, box and whisker plot or box and whisker diagram. Okay, this one was taken from KZN Prelim 2021. Okay, paper 1, it was question 5. Okay, we have already discussed the picture of box and whisker plot or box and whisker diagram. Okay, now with this information, they say the box and whisker plots alongside shows the March test mathematical literacy results for 2019 and 2020 at Maranatha High School mathematical literacy classes. Okay, there you've got the two box and whisker plots. And as you know, you should be able to interpret this. You should know that this represents the minimum, okay, and that one is quartile 1 or lower quartile or 25th percentile. This one represents median, quartile 2 or 50th percentile. This one represents 75th percentile, quartile 3, okay, or upper quartile, and then there we've got maximum. But the other thing that you must remember is the box and whisker plot is actually divided into 4 quarters, and in each and every quarter, this one from minimum to quartile 1 is 25%, and then from quartile 1 to median is 25%, and from quartile 1 to median, yes, to quartile 2 is 25%, and this one is also 25%, and there we've got 25% as well. So each and every part is 25%. And then obviously between minimum and median it's 50%. And between quartile 1 and quartile 3 it's also 50%. Okay. So that will be the same thing with the other box and whisker. So this one is minimum, then it's quartile 1, quartile 2, quartile 3, and then maximum. Okay, now let us look at the next one. They say use the diagram alongside to answer the questions that follow. Use the diagram alongside to answer the questions that follow. 2.1. Write down the minimum, okay, and maximum marks for 2019. Okay, we know that minimum is the lowest value, okay, and then maximum is the highest value. In this case, it's going to be the lowest mark and the highest mark. Then we also have to make sure that we are going to use the correct box and whisker plot, because there's one for 2019 and there's another one for 2020. Okay, the minimum, there is our minimum for 2020, so we have to check, okay, up to date. And then the maximum we have to check, okay, there's the maximum, so our maximum is somewhere there. There's our minimum. Okay, so it means again you should be able to interpret the intervals, okay, because like this one you see is 10, so the next one can't be 11, because if you say 11, 12, 13, 14, then you get to 20. Okay, then you need to figure out what each line represents there. Okay, now what I will do, I will just calculate the difference of 20 and 10. To the difference of 20 and 10, so there's 20 minus 10, then I get 10, then I divide by the number of intervals. The number of intervals there is 1, 2, 3, 4, 5. So if I divide it by 5, this will give me what each line represents there. You can take any, even if you say 50 and 60, you say 60 minus 50, right? Then you get 10. Then you check the intervals there, 1, 2, 3, 4, 5. Then you say 10 divided by 5 is 2. So it means each one represents an even of 2. So this will be, if this is 10, this will be 12, 14, 16, 18, 20. If this is 90, this will be 92, 94, 96, 98, and then 100. Okay. So just make sure that you write it correctly, because you might make a mistake there, especially if you have to interpret the intervals. Okay, so in simple terms, we say now our minimum, you don't even have to do the calculation, the minimum is 12, okay, and then the maximum is 96. Okay, I think these are in the form of a percentage. Okay, right, so the minimum, if these are in the form of a percentage, will be 12% and the other one will be 96%. Okay, so if the test was out of 100%, so the minimum mark is 12 and then the maximum is 96. Okay, so that's the answer for number 2.1. Okay, then number 2.2. The class of 2019 had 120 mathematical literacy learners. Calculate the number of learners who got a mark that was less than the lower quartile. Okay, lower quartile as well as the value of quartile 1. Okay, the class of 2019 had 120 mathematical literacy learners. Calculate the number of learners who got a mark that was less than the lower quartile. So in this case, our lower quartile, there's our lower quartile. So the mark there. Okay, I hope I got it right. Let's see again the interval. Okay, we need to answer two questions here. The number less than lower quartile. Less than lower quartile, it means 25%. Remember, lower quartile is this one. Then we know that less, it means it's 25%. So there's 25%. Okay, so we can simply just calculate 25% of 120 learners. So you say 25 over 100. So multiply by 120. So this will be, you take your calculator, 25 divided by 100, multiply by 120, then it's 30. The number of learners is 30. The number of learners is 30. Okay, then again they say as well as, okay, calculate the number of learners who got a mark that was less than the lower quartile as well as the value of quartile 1. So now the value of quartile 1 here, again interpretation, 30 minus 20 is 10. Okay, then we say 10 divided by the number of intervals there, 1, 2, 3, 4, 5, 2. So this will be 22, 24, 26, 28. So quartile 1 is 28. Okay, it's 28. Okay, then calculate the interquartile range, IQR, for the 2020 class marks. For 2020, we now look at the box and whisker for 2020. Again, if you think about the picture, if you label it, you know that this is minimum. Okay, this is quartile 1. This is quartile 1. That is quartile 2. That is quartile 3. And that is maximum. Okay, then interquartile range, it means IQR, it's equals to Q3 minus Q1. Right, Q3 minus Q1. Now we need to figure out what our Q3 is. Remember, for 2020, Q3 somewhere there, and then Q1 somewhere there. Again, in terms of intervals, the same. I think we've already done this. So it means this is 22. That is our quartile 1. Quartile 1 is 22. And then quartile 3 will be 52, 54, 56, 58. Okay. Once we got our quartile 1 and quartile 3, we'll be able to calculate interquartile range. So there we say 58 minus 22. Then if you use a calculator, make sure that you use your calculator all the time. And then we get 36. There's the answer for number 2.3. Okay, remember, for box and whisker, you only be expected to answer questions based on box and whisker, not to draw it. Then the next question, still based on the very same diagram. Compare the two box and whisker plots and decide on the class whose learners performed better in the March test. Justify your answer. Okay. Remember, what is indicated on the box and whisker is just a summary. Okay, it is just a summary. Okay, so if we have to write down the following information. This is the summary of 2019. Now the results in 2019, the lowest mark, which is minimum, if you check there, we said is 12. So let's say 2019, okay, the minimum was, okay, the lowest is 12. Okay, and then for 2020, okay, minimum, it's for 2020 the lowest mark there was 10. So if you check there, okay, so the lowest mark in 2019 was 12, and then in 2020 10. Then let us look at the other values. Quartile 1 for this one is 28 for 2019, and then quartile 1 for 2020 it's 22, and then quartile 2 or median in 2019 it's 42. Okay, in 2020 it's about 42, 44, 46. So 46. Okay, and then quartile 3. Now quartile 3 for 2019 it's about 68. Okay, okay, and for 2020 it's about 58. Okay, then maximum, that is the highest mark in 2019 it was about 96, and then for this one 82. Okay, so that means that this is the summary of the marks. Okay, the lowest learner got 12. Okay, but what does quartile 1 mean? If it's 28 in 2019, remember there we said is 25%. Okay, so it means if it's 28, 25% of learners had got 28 and less. Okay, and then 75% of the learners, that remember the remaining percentage. Remember we said this is 25, this is 25, this is 25, and that is 25, and this is actually quartile 1. So if quartile 1 there is 28, then we look on the left hand side, we say what is the remaining percent, what is the percentage on the left hand side is 25. So 25% of the learners got 28 and less. And then on the right hand side, the whole percentage out of 100 is 75. So 75% of the learners got more than 28. Okay, and then for quartile 2 represents 50%. So 50% of the learners got 42 and more. Okay, 50% got 42% and more, and then again the other percentage, the other 50% that is on the left hand side, they also got 42 and less. Okay, then quartile 3, 75. Okay, that one is on quartile 3. Quartile 3, it means only 25% got 68 and above, and then 75%, because now the percentage on the left hand side is 75, so they got 68 and less. But now if you analyze, if you check the results, you can see that in 2019 everything is bigger than in 2020. Okay, everything is bigger than in 2020. So for this one, when they say compare the two box and whisker plots and decide on the class whose learners perform better in matched test, then you can say 2019. Okay, you can say minimum is higher, quartile 1 is higher, quartile 2 is higher, quartile 3, and also the maximum. Okay, then the next 1. This one was taken from Mpumalanga Province Prelim 2021 Paper 1 Question 3. The box and whisker plots alongside summarize the hourly wages in American dollars of employees at two different fitness clubs. The fitness center club employs 24 employees and the fitness plus club employs 40 employees. So you can see each box and whisker plot with the name, the fitness center club and the fitness plus club. Okay, they look more or less the same, or they sound more or less the same, but they are not actually the same. Okay, so this is the information that is given. Okay, right, then they say use the information in the box and whisker plots to answer the questions that follow. What percentage of employees at fitness plus club? Fitness plus club. Okay, is this one? Okay, fitness plus club and an hourly wage of $14 and less. What percentage? Now we have to look at where the $14 is. There is 14. Okay, again in terms of interpretation, you can see that it's 15 minus 10, so you get 5. So in terms of interval, 1, 2, 3, 4, 5. So each line represents 1. So this is 11, 12, 13, 14. So this is where we find our 14. So this is on quartile 1. Okay, the question is what percentage of employees at fitness plus club and an hourly wage of $14 and less. So less will be on the left hand side of quartile 1, that is 25%. So the answer there is 25%. Okay, then number 3.2, calculate the interquartile range. Again, there's IQR. You should know this by now, Q3 minus Q1. But again, we have to make sure that we read from the correct plot or from the correct diagram. The fitness center club, so is that one the top one? We need to determine the quartile 3. So quartile 3, somewhere there, and then quartile 1, somewhere there. When we interpret, we've already interpreted the intervals. We know that each line represents 1. So this is 15. So that is our quartile 1. So quartile 1 is 15. Quartile 1 is 15. And then quartile 3 obviously is 21, and then it's 22. So it's 22. Then now we can do the substitution. 22 minus 15. Okay, so this one will give us 7. Okay, so boys and girls, we still have more activities, but unfortunately time is not on our side. So I hope you have enjoyed the lesson. So, and then we're going to continue next time. Thank you very much for watching. Goodbye.